Conference. This is the answers explaining session for last four questions. As usual, first of all, let me see the today's question. This is our today's question, which is from our topic fluid mechanics. The question is that which of the following statements are true when the cavitation parameter sigma is equal to 0? The statements give are: first, the local pressure is reduced to vapor pressure; second, cavitation starts; third, boiling of liquid starts; fourth, cavitation stops. Before entering into this question, first of all, we should know what is cavitation. Cavity, this word we have heard commonly with our teeth, which is nothing but formation of holes in the tooth is also known as cavity. Similarly, formation of holes in fluid machinery is also known as cavity. The process or phenomena due to which this cavity occurs is known as cavitation in fluid mechanics. Okay, this is one of the important topic everyone should understand clearly. Okay, when let us take the centrifugal pump. It will consist of impeller inside it, which rotates inside this pump, due to which pressure change occur, and as a result water will be pumped out from the sump. Okay, in this centrifugal pump, in certain region there will be a vacuum creation occurs. Vacuum is nothing but the low pressure, or there is no pressure, due to which the vapor pressure will be decreases, which results in formation of bubbles in the fluid, which then reaching the high pressure zone it will burst, due to which burst effect cavity will form in the fluid machinery parts. This is known as cavitation. In this question they have mentioned sigma. This term sigma we known as surface tension, but here don't compare with it too. Normally you look at the option, from the options itself we can finalize our answer. First option is 1, 2 and 4. The local pressure is reduced to vapor pressure when cavitation starts and cavitation stops. What is this? Cavitation starts and cavitation stops. That by seeing these two statements itself we can eliminate this option. Then option B, second and third, cavitation starts and boiling of liquid starts. It's okay, but here there is not mentioned the earlier stage. Okay, or in this option first option is too correct, they have not included, therefore this also we can eliminate. First and third, here also second option is not including, therefore this also not possible, hence eliminate it. Finally option D, which includes the local pressure. First of all, local pressure reduced to vapor pressure, due to which cavitation starts. As a result of cavitation, boiling of liquid starts. Therefore correct option for this question is option D. Okay, now let me enter into task 4 questions. This is the first question, which is from general aptitude. This is one of the very interesting question, because visualize it, will be more interesting. The question is: a wire would enclose an area of 1936 meter square. If it bent into a square, the wire is cut into two pieces. The longer piece is thrice as long as the shorter piece. The long and short pieces are bent into square and a circle respectively. Which of the following choices is closest to the sum of areas enclosed by the two pieces in square meters. Okay, I have solved this question. I will show you answer. Before that, you should understand this question. There is a wire. When we are bending this wire in shape of square, the area formation is 1936 meter square. After that, this wire is cut into two pieces. One piece is thrice long as the shorter piece. The long piece is then bent into a square and small piece is bent into a circle. Sum of these two square, the square and the circles areas is what we are going to find. Okay, now you can see the answer solved by me in the screen. First of all, given area is 1936 meter square. From this is of squares area, therefore we know that area of squares formula is a square. From this we can find the one side length, that is 44. Therefore total length of the wire will be, because square has four sides, therefore a into 4, we will get 176 meter, which is the total length of wire. This is cut into two pieces. Of one length is thrice as the others. Okay, therefore now we shall divide this total length by 4. We are getting 44, therefore one part is 44. This like 4 parts. Okay, from this we can find that 3 into 44, which will give the 132 meter, which is the length of longer piece. Similarly, small piece we know that 44 meter. Longer piece is converted or bented into a square. Therefore area of square, we know that formula a square. Before that we should know the length of one side. Therefore dividing 132 equally by 4, we are getting 33. Therefore 33 square is equal to 1089, which is the area of square. Similarly, in case of circle, there is a circle means definitely we should know that here circumference will occur. Therefore 2 pi r is equal to 44. From this we can find the radius. Using that we can find the area of circle pi r square, which is the 154. By summing of first and second, we will get the answer as 1243, which is in the option 2, I think so. That is the correct answer for this question. That's it. Okay, this is the second question, which is from our topic fluid mechanics. This is one of the interesting question, because here we are going to study about the concentric shaft bearing. Okay, in first of all I will read and explain you the question. In a simple concentric shaft bearing arrangement, the lubricant flows in the 2 mm gap between a shaft and the bearing. The flow may be assumed to be a plain Cauchy flow with a zero pressure gradient. The diameter of the shaft is 100 mm and its tangential speed is 10 meter per second. The dynamic viscosity of the lubricant is 0.1 kg per meter per second. I think so, here unit is wrong. The frictional resistant force Newton is per 100 mm length of the bearing is dash. We have to find the frictional resisting force. I have solved this. I will show you now. Okay friends, now look at the solution. Look at the figure. First of all, there is a shaft which is supported by means of concentric bearings. Okay, that is the bearing. Normally what is the purpose of bearing? It will support the shaft. Okay, and also main reason is it will give a support the shaft, and also for smooth rotation it will be very useful. Okay, first of all they given a gap, which is the thickness dy is equal to 2 mm converted into meter, 0.002 meter. Diameter of the shaft is 0.1 meter. Length of the bearing is 100 which is equal to 0.1 meter, and tangential velocity u is equal to 10 meter per second. Mu dynamic viscosity is equal to 0.1 kg per meter second. Is actually the unit is Newton second per meter square. Okay, here we are going to find the frictional resistance force. We know the general formula, which was derived. Tau is equal to mu du by dy. Tau is the shear stress, mu dynamic viscosity, du velocity, and dy thickness. We know that shear stress is equal to force per unit area. Substituting in place of tau, we can found the force, which is the frictional resisting force. Okay, that's a simple calculation only. Substitute the corresponding values. We know that all values, yes, if we substitute, we can get the answer as 15.707 Newton. This is the answer. Okay, that's it today. Subscribe my channel and click the bell icon to receive questions daily. Thank you.